In this video, we're going to talk about sample standard deviation as our last measure of variability, and then we're going to put it all together with some practice. So again, sample standard deviation is what we're starting with. So here is the formula for sample standard deviation. It's going to look really familiar. It's basically just like the transformation that we do with population variance to population standard deviation. We're simply taking the square root of the sample variance to get the sample standard deviation. So instead of having the variance formula of sums of squares divided by n for the population, we have sums of squares divided by n minus 1. We take the square root of it to find the standard deviation. We have this new symbol, which is an S, and just like with population variance, you have sigma squared, and population standard deviation is just sigma. Sample variance is S squared, and sample standard deviation is just S. So when you see the lowercase s, it's sample standard deviation. And it's a transform score. We've talked about this. It describes the spread of scores from the sample mean in their original units of measurement. We had to square the units in order to figure out variance, because if we didn't do that, all of our deviation scores would have a mean of 0, so that doesn't work. So we had to square them first and then turn them back into their normal units by taking the square root of the squared scores. So here's the first practice that we're going to do. We're going to calculate the sample variance and the sample standard deviation using this following information. I've given you the sums of squares, and now you can figure out sample variance and sample standard deviation. Pause the computer, try it on your own, and then come on back. So for this first example, we had a sums of squares of 36 and an n of 5. We're trying to figure out the sample variance and the sample standard deviation. But in order to do that, we need to figure out the degrees of freedom. And the degrees of freedom is n minus 1. 5 minus 1 is 4. So our sample variance is going to be 36 divided by our degrees of freedom of 4. So our sample variance is equal to 9. And our sample standard deviation is simply the square root of 9. So our sample standard deviation in this case is 3. For this next learning check, I'm going to have you calculate the sample variance and sample standard deviation using this information. We have a sums of squares of 196, and our n is equal to 5. Pause the computer, try it on your own, and then come on back. For this next example, we had a sums of squares of 196, an n of 5. We need to find the sample variance and the sample standard deviation. Before we do that, we need to find the degrees of freedom, which is n minus 1, or 4. So now I can figure out my variance for the sample, 196 divided by 4, which gives me 49. So my variance for the sample is 49. And my standard deviation is going to be the square root of 49. So the sample standard deviation is equal to 7. So for this last learning check, we're going to put it all together from the very, very beginning. You're going to take this sample of n equals 7 scores, and we're going to calculate variance and sample standard deviation. I want you to try to do this on your own first, and then we'll work it out together. For this next problem, we're going to need to make sure that we have this array set up that's going to help us to find the sum of squares. We need the sum of squares to be able to figure out variance and standard deviation for the sample. So let's go ahead and figure this out. We are given this set of scores, and I know I'm going to subtract the mean from each set of scores in my first step of getting the sum of squares. And so in order to do that, I need to figure out what the mean is. So let's sum up all of the scores. 19 plus 7 is 26, 31, 35, 39, 42 is our sum of all of the scores. Now, how many scores are there? 1, 2, 3, 4, 5, 6, 7. There's 7 scores total. 7 goes into 42 6 times, so I know my mean is going to be 6. Now, I have degrees of freedom here because I'm going to need that for later. So if my n is 7, my degrees of freedom are n minus 1. 7 minus 1 is 6. So I'll just leave that there. All right, let's go back to finding our sum of squared deviations, or our sum of squares. We're going to take each number and subtract the mean of 6. So 3 minus 6 is minus 3. 4 minus 6 is minus 2. 5 minus 6 is minus 1. 7 minus 6 is 1. 8 minus 6 is 2. 11 minus 6 is 5. Now remember the trick. I always want to add this up, this deviation column up. It should add up to 0. And that, if I do that, I know that I've done it right. So negative 3 plus negative 2 is negative 5, negative 7, negative 8, plus 1 is 7, plus 2 is 5, plus 5 is 0. So these all add up to 0. I know I'm good. There, I've done the right thing. So we're not done that, though. We have our deviations, but we need to square our deviations. So I'm going to do that. Negative 3 times negative 3 is a positive 9. 2 times 2 is 4. 4, 1, 1, 4, and 25. Now what we have to do is we have to sum up all of those squared deviations. So 25 plus 4 is 29, 30, 31, 35, 39, 48, right? So our next step is to take our sums of squares and divide by n minus 1, or our degrees of freedom. So 48 divided by 6 gives us a sample variance of 8. And to find the sample standard deviation, we just need to take the square root of 8, which is equal to 2.83. You'd have to do that on your calculator, but that is our sample standard deviation. So let's see how we can interpret this. On average, the scores here vary by 8 squared units, which we never like to talk that way. So we're going to say instead that on average, these scores vary from the mean by 2.83 units, or 2.83 points. All right, so this is the answers to this problem. All right, let's take a look at the next one. Let's do one more using a table, a frequency table. We're going to find the population, mean, variance, and standard deviation, and then we're going to find out what percentage of scores is 4 or higher. Pause the computer, try it on your own, come on back. For this problem, we're being asked to take this frequency table and pull out the scores so that we can figure out the population variance and the population standard deviation. So let's pull out the scores first. How many scores do we have that are 1? We have 2. So I'm going to put 2 1s here. Get rid of that. How many scores of a 2 do we have? We just have 1 score of 2. We have 3 3s. We have 1 that is a 4. And we have 2 scores that are a 5. All right. So now we have the scores ready for figuring out variance and standard deviation. So if you will recall from the question, we're looking for the population variance and the population standard deviation. We're kind of going back away from samples, now we're back to population. So let's take a look. The very first thing I know I'm going to need to do is subtract the mean. To figure out the mean, I need to total up the scores first. I have 5 plus 5 is 10, 14, 17, 20, 25, 27 is the total number, or the values all added up. I need to put the n here, didn't put that there. That's how many scores we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my mean is 9 goes into 27, so I have a mean of 3. Now I have everything I need to know to find sums of squares, population variance, and population standard deviation. So here we go. We have 1 minus the mean of 3. That makes it negative 2. Negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0 a couple times here. 4 minus 3 is 1. 5 minus 3 is 2. And 5 minus 3 is 2. So when I have deviations, I want to do a check just to make sure that they add up to 0. So I can see that they are going to. I have 2's and a 1 and 2 negative 2's and a 1. They're going to cancel each other out. This is why we can't find the average of the deviation scores, because the mean would be 0. So we're moving on with that. Okay. So now we come to square our deviation scores to get to sums of squares. So we have 4, 4, 1, 0, 0, 0, 1, 4, 4. So that's all these scores squared. And sum of squares just means add up all those squared scores. So we have 8, 9, 18 is the total. So our formula for population variance, again, is sums of squares divided by n, not sample variance, but population. 18 divided by 9 is 2. And then if you take the square root of 2 and you do it on your calculator, you'd end up with 1.41 is the standard deviation. So we could say that these scores on average vary by 2 squared points. It's kind of weird to say. Or when we return it to standard deviation, we can say these scores vary from the mean on average 1.41 points. This is much more easily understandable. All right, let's go to part 2 of the question. We're back to our frequency table that we started with, and the question was, what percentage of the scores are 4 or higher? So let's first of all circle 4 or higher. These are the scores that we're interested in. What percentage are these scores of the total? So let's first figure out how many scores there are. There's 2, 3, 6, 7, there's 9 total. How many scores are 4 or above? That would be 3. So we just do a little division. 9 goes into 3. And the answer to that is 3.3333. It goes on and on. Or you can just say 33.33% of the scores are 4 or higher. And that's how you answer that question. Let's summarize what we've learned in lesson 4. We talked about dispersion as a description of a spread of scores in a distribution. We also talked about population variance and standard deviation. And then we went into sample variance and standard deviation. We talked about how samples have less variability, so we must adjust. And we also talked about how 68% of the scores are within 1 plus or minus standard deviation from the mean, and that 95% of the scores are plus or minus 2 standard deviations from the mean. So that's a good summary of our lesson 4, and in the next lesson you're going to learn about something called z-scores. We have one more video in this lesson, which is walking you through finding standard deviation and variance using Excel.